So hey guys, welcome back to my channel. Hope you are doing extremely well. This is your very own mask coder this side. Okay, so continuing the GFG POTT series, we have already completed 28 of our days and today is day 29th. Okay, so today's problem is insertion sort for singly linked list. All right, let's see what does the problem say. So the problem is we have to do the insertion sort for singly linked list. Okay, the prerequisite for this problem are we have to understand what is the meaning of insertion sort, like how does the this sorting algorithm works, and what is a singly linked list. I hope all of you know about singly linked list, and many of you would know about what is insertion sort, that what is the algorithm used behind it. For those who don't know, I'm explaining in this very video. Okay, so insertion sort is type of a sort that sort the numbers as you would sort the playing cards. That is, pick an item from the unsorted collection and put it at the right place in the sorted collection. That is, suppose you have a collection of, let's say, 30, 40, 70, then 10, then 11, then 15, then 60. Okay. As you can see, this is an unsorted type of collection or array or data structure, anyone you want to say. Okay, now I would have to sort it. So what I will do is I will pick the first element, that is 30. Keep it with me. I will pick 40. Now I see that 40 is greater than 30 actually. So I will put it after 30. Okay. Then come to 70. After 40 it will come. Okay. Then 10. You see the 10 is smaller than all these numbers. So 10 will come at the first position. Then 11. It will come at the second position. So 11 will come here. Then 15. Between 11 and 30. Okay. Then 60. Between 40 and 70. So this is your order collection. That is 10, 11, 15, 30, after that 40, then 60, then 70. This is your insertion sort. That is, pick an element from the unsorted collection and put it into the sorted collection. Now you have to do the same thing for the linked list. So let us take a smaller example. That is, suppose a single linked list of 4 elements. Let those elements be 30 connected to 23, connected to 28, connected to 11. Okay, this is your unsorted list. A sorted order would something look like 11, 23, 28, then 30, right? So this should be your final answer. How would you approach this problem? So as I discussed before, that just pick an element from the unsorted collection and put it in the sorted collection. All right. Before that, let me tell you how does the approach work in vectors. Okay, just to tell you for your insights, for vectors, the approach works something like this. Suppose you have got 30, 23, 28, 11 inside a vector. So what you will do is, first you will select, you will go from I equals to 1 up till end. That is from this index, after that this, after that this. Okay, so currently you are at I equals to 1. Okay. Now we will compare it with the I minus 1. If you see the 23 is less than 30. So what you will do, you will swap these two. So it will look like 2330. Right. You see that this variable cannot go further beyond it. So you will proceed your I. I comes here now. All right. So my array now becomes 23, 30, then 28, then 11. Okay. I is currently here. Okay. I will compare it with compare it with 30 and see, yes, it is smaller. So swap these two. It will come here. So it will be 28, 30. Now I will see that 28 is greater than 23. So I will stop my swapping here. So it will be 23, 28, 30, then 11. I plus plus. So I comes here. Now I see that 11 is less than 30. Swap it. It comes 11. It comes 30. 11 is less than 28. Swap it with this. So 11 comes here. 28 comes here. 30 comes here. 11 is smaller than this. So 11 comes here. 23 comes here. 28 comes here. 30 comes here. And no more swaps are allowed. And also my array has reached the end of the array. So I have to call off my iterations. And this is my sorted array. You can see that the array we have got is sorted. This is my O of n square solution for vectors, and it is using constant extra space, that is O of 1 space complexity. All right. Now many of you would say that implement the same approach on linked list. You're very fine. But there is a mistake in that. What? Suppose you are comparing these elements. Okay. Now 23 is less than 30, correct? But to swap these, you can in the vector you can go to I minus one index easily, right? But in the case of linked list or single linked list for precision, singly linked list, there is no pointer for previous one. If it was a double linked list, it would be the same. Okay, it would be very easy then. But for singly linked list, there is not previous, so we will have to traverse the whole array up till we reach the temp next is the pointer we already are at. So for that, it will be O of n cube. Why? Because in this only solution, it was traversing O of n square, and we could reach the I minus one index in O of one operation. But to reach the I minus one index here, we have to traverse O of n vectors again. So it will be O of n cube, which is pretty inefficient. So to avoid this type of confusion, by the way, this is your brute force solution, kind of brute force. Not exactly brute force, I will tell it as efficient, right? Brute force is store the elements in the vector and then sort the vector by using the insertion sort, then put the elements back into the linked list. All right, that will be the brute force. Now, for the optimized approach, what you will do, you will just follow the definition. Just follow the definition of insertion sort. Now, before I tell you the optimized approach, I would really appreciate if you just subscribe the button. If you just hit the subscribe button and the like button below the video, it gives me a lot of motivation. Okay, moving on to the optimized approach. So, for optimized approach, what was the definition? Element selected from unsorted and move it to sorted. Okay. So suppose my linked list is 30, 23, 28, 11. This is my head right now, right? I make a head as answer and assign it null right now. All right. Then I will move my head to answer and store next here. That is next is currently heads next. Okay. I will move my head to the answer. How? Now if answer equals to null, like insert the head into the current position of the correct position in the answer array. Answer is currently null. So what will be the first element in the answer linked list? It will be head only. So it will come 30 here. All right. And head will come here. Next will come here. Right. 23. Now my answer is currently 30. 23 is less than the value of answer. So 23 will be inserted on the left. All right. Change it to next and answer will come here. Okay. My head comes here. Next comes here. My head is 28 right now and 28 should come somewhere in between. So what I will do is I will create a pointer and I will traverse until temp's next value is less than equals to 28. When I will reach the condition, so insert 23, 28 here, 23, 28, 30, and answer will remain same because 23 is still the first element of the linked list. After that, head comes here, next comes here. All right. I have to insert 11 and 11 will come here. Okay. This is my final linked list and return your answer. Now, many of you will say that you are using n square O of n square complexity. Yes, I'm using O of n square time complexity. Why? Because for each element in the unsorted linked list, I'm using O of n. Maximum O of n can occur. That all the elements are occurring at the last. That is, it is already a sorted linked list, and I'm again sorting it. In that case, it will be O of n square. That is, in case of sorting a already sorted linked list, worst case will appear. All right, I hope you understand. Okay, now O of n square time complexity achieved. Now many of you will say that you are actually copying the elements, so it will be O of n space complexity. But no, I'm not copying the elements. I'm moving the elements from here till here. That is, if I'm inserting 30, 30 is not anymore here. 30 is actually only here. If I'm inserting 23, in 23 is removed from here and inserted here. Similarly for 28, similarly for 11. All right. Now, how will I do it? For that, I will have to write the pseudocode. What is the pseudocode? The pseudocode would work something like this. That is, my main function, my driver function would something look like I have the head in my hands. Okay. The first base condition is that either head is equals to null, that I have got no element, or my head's next is equals to null. That is, I have a single element in hand. For a single element, sorted order is the single element only. For in that case, return head. And this base condition is actually valid for many of your linked list questions. Okay, so keep that in mind. Okay, if head equals to null or head's next equals to null, in that case, return your head. All right. Now my main algorithm works. My main algorithm works like I will create an answer for my sorted array and assign it null initially. Okay. Then while my head is not equals to null, what will I do? As I did above, my next node star next will be equals to heads next. All right. Now my answer will be equals to updated answer after inserting the head into the sorted answer linked list. After that, my new head will be next. This was what we're doing. We were just updating head and next, head and next, head and next. As you can see, our head was initially here and next was initially here. Then it moved one again. Then it moved one forward. Then it moved one forward, right? And we stop when head comes here at the null position. Okay. So now this is my driver code. All right. I just have to implement the insert function, and that is the slightly tricky part. Not tricky if you will be able to visualize. See, I always say that linked list is about visualization. All the other questions are about thinking and are about learning, but linked list is the easiest topic of DSA if you master it, because it will fetch you easy marks, and it is just about visualization. That where is the next pointer right now? Where is the temp pointer right now? So just visualize it, just draw it in your mind or draw it in your pen paper for the better visualization. So now I will have to implement my insert. As you can see that insert will be reverting back me my answer. So it will be of type node star. The name of the function will be insert, and it will take two nodes. That is insert, and let me name it as new node. So now the first condition is that if my answer equals to null. Now, as you can see here, when my answer was null and I got 30 as my first value, so what did I do? I just put 30 at my answer and returned. So in that case, what you have to do, if my answer is equals to null, then implement your mind. What we have to do, we have to remove 30 from here and move 30 here. For that, what I can do is, my answer is currently null, and I have 30 in my hand, and 30 is attached to a linked list. So what I will do is, I will do 30's next is null and then move answer here. Right? Just say it with me. I will I will do 30's next, point to the null that is current my answer, and then answer my new answer will be 30. Right? No problem. So what I will do is, my new node next equals to answer, which is currently null, and then answer will be my new node. All right. My else if condition is, as we discussed, that when after inserting 30 we got to 23. So what did we do? We inserted 23 before, we assigned 23 as next of 30. That 23 is next is 30 and moved answer backwards. So similar operation as we did above. That is, if answers data is actually greater than new nodes data, only then it will occur. New nodes data, in that case, my new nodes next is equals to answer, and my answer will become new node. Correct? This is what we discussed. And as you can see, these two implementations are same, so I can use a or operator instead of making if and else if. All right. Now comes my last condition. That is, if both of them are not submitted, then it will have to submit in the further of the dictionary, further of the linked list, sorry. So for 28, what did we do? We had 23 and 30 in our hands. Our answer was here. So what did we do? We created a temp here, okay, and moved until temps, until, let me write it here, until temps next value is smaller than new node's value. Because if it is greater than new node's value, then new nodes would have to be submitted before it. So we are taking the next value. That is, if it would have been let's say 24 and we have to insert 28, so it will have to insert it here, right? But it is 30 and we are standing here, so we have to predetermine that it will go here or it will go here, right? So for that I am using the temps next value and not the temps value. For that, what I am doing is, else my node star temp will be equals to my current answer, all right? And then while, right, now there are two conditions. Either temp reaches the null, the last of the array, that is, suppose this is my x and it is pointing to null. My temp reaches here. If my temp reaches here, I will have to insert my value here only, no other option. So while temp next is not equals to null, and temp next value is less than equals to new node value. In these cases, what we have to do, we have just to increment the tab 10. And when this while loop ends, what we have to do is 23 was here, right? 30 was here, right? Answer was here. My temp started from here. I have to insert 28. All right. I have to insert 28. So my 28 will go here. I see that temp's next value is actually greater. So I will stop my temp here only. And then what I will do is, my new node is this, a linked list is attached to here. What I will do is, new nodes next will be equals to temps next. That is, new node next will be equals to temps next. That is, instead of pointing here, it will point here. And then my temps next is 28 right now. So my temps next will be equals to new node. Simple insertion. I don't think there is any. If you are clear with the basics of a linked list, this is the first lecture of linked list, that is insertion at the rear end, at the front end, or in the between. And then after that, you learn about deletion, etc. So just I'm doing is, I'm inserting at right places. Okay, only the conditions are new. Otherwise, this is simple insertion. This is simple insertion, and that is why the algorithm is known as insertion sort. All right. So what is the time complexity now? Time complexity, as we discussed, O of n square, because in the worst case, we will be traversing the whole linked list we have made in the sorted order and then return it. And space complexity O of 1, because we are not using any extra space to store the elements. All right. I think I'm clear. Moving to the code section. But once again, I request you to please hit the subscribe button. It means a lot to me. All right. So insertion sort code for linked list. I will walk you through it. What we will do is, if the base condition is, if my head is not present, or my heads next is not present, in that case return head, right? This was the base case. After that, my new answer will be currently equals to null. Now just a minute, I am changing the name of the head ref to head, okay, to keep it short and easy to write. Now while my head is not equals to null, in that case my next will be the current heads next. My answer will be, insert the element at head into the linked list answer, and then my head will change to next, and after that return your answer. This is my driver code, right? I just have to implement the insert function. For that, it will return node star because it is running the answer head, and now it will take name is insert. Now it will take two nodes as arguments. First one is my new node, and then my sorted linked list heads node. Now first condition is if answer equals to null. In that case, what we were doing is new node next equals to answer, and then answer equals to new node, right? My else if condition was if answers data is actually greater than new node data. In that case, same of the two lines we discussed, right? Same two lines. I could have used or operator, but I am not adding the or operator for your more clarity. Else what you have to do is else create a node star temp which will be carrying answer first, and then while temps next is not equals to null and temps next value is actually less than equals to temp is actually equals less than equals to new node data, and it will be instead of value it will be data here also. Sorry for my mistake. Yeah. Now when this until this is reached, just increment your temp, that is move it to the next pointer. After it is reached, same steps, new new nodes next it will be equals to temp next, and then temp next will be equals to new node. Actually these two steps are also similar to these two steps only, these two steps, right? Just you are increasing temp, right? Just you are using temp instead of answer. After both of these if else condition, just return your answer, new answer. Okay, and then compile and run. Hope it works. I have not committed any compilation error or typing errors. Running fine for compile and run. Try it out for submit also. Running fine. Thank you guys for watching, and it's our 29th day. It was a complete we have completed our 29-day streak. This was not possible without you, and please subscribe to my channel. Please subscribe to my channel. And I'm disappointed to say that most of my users have not subscribed to me, and the number is huge. So it's sincere request to please subscribe my channel. Thank you. Have a nice day.